Hello and welcome back to CodeBugs. In this video, we'll be going through a journey of how to select your college project, right? So this is not a guide, but it is simply to let you know the thought process behind selecting a college project, right? So this is a problem that a lot of college students are facing. There are hundreds and thousands of projects readily available in the internet, right? But you need to know what to take, what is best for you, which project can we understand a lot of. Is this project viable? Is this project can we add something unique to this project? To understand all this, I'm going to take you through a thought process of how to select a particular project. So the first thing that we can do is simply ask the internet for project ideas, and after ChatGPT has come, it has become very easy. I'm gonna ask ChatGPT first. Okay, yeah, we have ideas now. We have image classification, we have sentiment analysis, fraud detection, recommendation systems, predictive maintenance, right? So we have NLP, medical diagnosis. So we have all this. After we pick, let's say, image classification, now what is the next step? What are the steps to be followed to create a machine learning project? So once we have this name of the problem, we have image classification, but we do not understand what the problem is. We need to understand what exactly we're going to do. So build a model that can classify images into different categories such as animals, vehicles, or household items. After we understand the problem, we need to make sure that this is a viable project. After I build a model that can classify images into categories, what should I do with it? What is the use of this project? Who are the target people that I can sell this project to? A university will expect you to create a project in such a way that this can be used in real life. That is something that is very important for them, because you can simply create anything, right? Everything is there in the internet. Whatever is there in the internet, you can simply recreate it and then show them. But did you understand what is the use of that particular implementation? Where can it be used? What is one unique thing that you can add it to the already existing project so that it is something unique now that you have made? So define the problem. Yes, okay, we can define the problem however we want. We need to make sure that it's viable, right? And prepare and collect the data, right? So I'm going to go to Kaggle. Kaggle is a data science company, and their website contains a lot of information ranging from competitions to models to pre-trained models to code and discussion and data sets. So everything is there. So I'm going to go to data set, because we right now we need a problem and we need data. Is we're going to look at this data set, right? So we have arms inputs per country. So let's go see how the data is. So we have the countries in alphabetical order, and we have in 1950 the number of arms imported, 1951, 52, 53. So since it is there till 2020, create a model that can predict the amount of arms that the country will import in 2021. If we have this particular data, we can move towards that kind of an outcome. We need to find an algorithm that can take this data, train itself on it, and create a prediction. One thing we need to answer ourselves is that really necessary? Is that something viable? Is that something that people can be benefited from, right? So what is the use of predicting the number of arms a country will import in the next year, right? So obviously it won't be exactly of how we predict, because again, if there are wars, if there are other factors that other factors that influence this particular decision of that country, again, it's all to waste, right? So this is not something that is viable, but it's giving us some kind of a thought process, right? So now we are understanding that if we have data like this, some from this year to that year, and we can have a prediction of what it can be in the next year. So this is something like a prediction model. So this is something that we can start out with. Like, we started with nothing and now we have something that we can move about with. Let's look at other data sets for better clarity. These kind of data will not help us now, because the kind of thing that we are looking for is a prediction. Movies data set won't help us. Car prices won't help us. Accident data might help us, right? So we'll go to all data sets. We'll see a wider variety. Oh yes, we have COVID cases and deaths worldwide, and the usability is 10, which means a lot of people are using it. right? So we'll look at this data and we'll see if something can be done. We'll look at the data. The data is the country and the total cases, total deaths, total recovery. We have active cases, we have the total tests and the population. This is a event that has happened already. There is nothing new that is going to add to this event. This event has already happened, and all you can do is analyze this event, right? So this kind of a data can be used only for an analysis. It cannot be used to bring some kind of a trend, right? So because COVID is kind of over now and we don't have these many cases that are going on, and there is no use of predicting anything right now. If you have a doubt of how to use this data, just go to code. Just go to the code that they've used this data set for. So this will be a little bit around the analysis of how this data is. So which country is the highest, which country is the lowest, something like that. So that kind of information, a report can be produced, right? So now we have two schools of thought. One is creating a report on already existing data, a report so elaborate that it kind of describes the whole event, right? You can create a holistic view of how much deaths are there in each country, what kind of testing that they're doing, how much testing that they're doing, how is it related to the population, and everything like that, right? That is the best thing that can be done with this particular data. One more thing that we observed here is that this is an EDA. EDA stands for exploratory data analysis. EDA generally means that he's describing the data with numbers and plots and graphs and everything. As you can see, each and every cell is an extrapolation of that particular data. So we have info, we have the shape of the data, we have the columns, and we have the sum of the columns, and talking about total deaths, right? So these are very important information that can be taken from this particular data set, right? So I think percentage of patients death and yes, this is something that's very useful. Top 10 cases, so USA is the highest number of deaths, and the bottom 10, I guess, top 10 less cases indicates the bottom 10. Yeah, so Falkland Island is 0, and this is around 14. So this is the top 10, this is the bottom 10. So now that gives a holistic view of how the deaths are distributed, right? So which country has the highest amount of deaths, which country was hit the hardest, and you can compare that to the population of that country, create a correlation analysis and everything, right? So this is an analysis report that you can produce. You're not processing the data to get something new out of it. This is just a report. So this is one school of thought, right? So we'll look at other values, other data set. So I'll go to all data sets again. Top 100 songs, shop customer data. So these are very static data, right? So top 100 songs, I don't see a very useful information that I can predict or make a report from. Yes, yeah, I can make a report about the top 100 songs that is there. But again, we need to look at the usage of it. We need to look at the impact it creates, right? So again, 250 movies data set, countries temperature statistics. Again, this is something like a weather plus time series data. So that can be used for prediction. So that we saw in the ARMS data set. And yes, this is something that can be very useful. Tesla stock price from 2005 to 2023. This is a very impactful value. Tesla is a very impactful company, and the stock price till 2005 to 2023. So that's a huge data set, right? So as we saw in the ARMS data set, this is a very time related data that ranges from 1 year to another year. And one thing we can do is predict, right? So predicting stock prices is obviously a very cliche idea that is there. But let's see what we can do with this, right? So we'll see what other people have done. So other people have done an EDA, and yes, there is one program here. So they've used XGBoost for Tesla stock price. Okay, so the moment you see a new word, you Google it, XGBoost, or you ask ChatGPT, whichever suits you, right? So XGBoost, what is XGBoost? XGBoost, which stands for Extreme Gradient Boosting, is a scalable, distributed, gradient boosted decision tree machine learning library. It provides parallel tree boosting and is the leading machine learning library for regression, classification, and ranking problems. Right. So regression is something that deals with time series data. Regression is like extending an already existing trend to new values, to predicting new values, right? And classification is just subdividing an already existing data into different classes. And ranking obviously is pretty self-explanatory. And so now you have an idea of where we are starting from, where we are going, and what we'll be using. So we have Tesla stock price in hand. We are going to predict the stock price, and we are using a model, that is XGBoost, to do so. When you're thinking like this, some of you might have this idea that why XGBoost, right? So I have a stock price, I'm going to predict it, and you're telling me that I have to use XGBoost. Can you suggest me some algorithms to use for stock prediction similar to XGBoost? I have an algorithm XGBoost, and now I have algorithms that are similar to XGBoost that can be used for stock prediction. Now my thought process is going like this. How do I know which algorithm to use for the best outcome to predict stocks? How do I know what kind of parameters that I need to give for XGBoost itself for it to give the highest amount of accuracy that it can give? So this thought process is leading me into another problem statement, a comparative study between a set of algorithms for predicting stock price. So I will use this as an example to illustrate. But once that gives me the idea of how each algorithm behaves when it is trained on a time series data like stock price, I can now give a holistic report on how each algorithm is performing. What is the consequence of change of each parameter inside that algorithm? Like for example, if I'm training a parameter for let's say 100 epochs or like 200 epochs. Now what if I change that? Right, so that is one parameter that I can create a study from. Or what if I use completely different kind of let's say a CNN here. It is used for image classification, right? It is very much useful for image data. So how can I use that here, right? So what is the comparison between using CNN for image data set and using CNN for a time series data set, right? So within like 5 to 10 minutes, I've created like 5 to 10 schools of thought here. So I can use stock price, I can compare algorithms within the same data set, or I can use one algorithm, I can use two different schools of thought within that same thing, or I can take a data set, create a holistic view of how it is distributed and everything, create an analysis report on it, right? So the one thing that is unique here that the university might appreciate is we already have a code for using XGBoost to predict Tesla stock price. But the unique flavor that I'm bringing from my end is the comparative study. Why can't I, the questioning that what makes XGBoost a good predictor or an algorithm to use for stock price? What makes, let's say, SVM? What makes SVM a good algorithm for predicting stock price, right? So after I have a holistic report of all these, of the accuracies of all these algorithms on the stock price, now I'll be able to understand which algorithm is doing best and why it is doing best. Now, when I'm doing that kind of a project, there are 100 different things that I'm touching at the same time, right? There are so many topics that I'm covering, and my knowledge on machine learning will improve significantly when I'm doing the project like this. A lot of sources on the internet just give you the answer, they just spoon feed the answer, so the learning curve is very, very less, right? So just to sum up on what we have seen, if you have no idea on how to start a project, first see what are the important things that you need to start with a project. For example, right now we needed a problem statement and we needed some data, and we just went to a website where we can find both. And after I went there, I got hundreds of ideas from other ideas, right? So I didn't create anything new. I just took what people already had and I increased the scope of it, I increased the quality of it, I put multiple other parameters inside, and now it's a fully complete project that I have in hand right now. I hope you understood the thought process behind creating a complete project from scratch. So thank you so much for watching this video. Hope you understood. Hope you liked this video. Bye.